Hi, everyone. Thank you for joining us today. I'm Harshit, and I am a senior software engineer at ImageKit. Been here for about 2 years, and I primarily work in video APIs, and I think that's where we are going to talk about video experiences in React apps today. So before we start with our talk, I would want you to estimate how much of the global internet traffic is videos today. 50%? Uh, 70%, 90%. Well, sorry, 88%. Well, I think we are getting very close here. So it is 80%, and now when it is 80% and it keeps growing, right? Because we are only going to go up from here. Now, because when we see that 80% of the traffic of the global internet is videos today, it is very imperative that we make sure that our video experiences are just up the notch, right? So when we talk about videos, they are the present and the future of marketing. Because when you look at a product video or a short form content, or let's say you are building an app, an e-commerce app where your users are uploading some user reviews, everything has videos, right? So for example, I have Amazon here. So this has a product video. This also has some customer videos, right? So in a way, videos are just, going to take over the internet in a few. So we are at 80%. We might just soon touch 95% in no time, right? So now when we talk about videos, we have to make sure that they are most optimized. We don't, the users have less patience. We don't really wait for so long for our videos to load, right? So it is very important that we kind of make sure that the video experiences are top notch and they are quick. There's less buffering. We do not, compromise on the video quality. Now, when you were to, kind of integrate videos in your applications, most people would argue that, probably a platform like YouTube would be the best because it is free. It also gives you this distribution and search traffic. So for use cases where, let's say you wanted to upload a video and you want, a global distribution mechanism where people could actually search and find your video even on Google using SEOs, YouTube is the place to go, right? And you don't need to set up any infrastructure as well, because YouTube has their own platform. You can just upload a video. You can even do some editing on the platform, and you can just, serve it directly. Now, typically, how would you implement a typical YouTube in your application? The most easiest way to do this would be, let me probably go to the code. So the most, is it visible? Or let me just zoom. Yeah. So the easiest way would be to just, go to an iframe, use the iframe tag, and just embed a simple YouTube using the link that you have, right? Now, while this is the most easiest way to embed videos in your applications, this has certain disadvantages, right? So for example, YouTube has a lot of ads, right? And these ads are not just on the platform, but also on the embeds that you do. So for example, I have a sample app, and oh, by the way, we will be looking at a lot of these examples during the whole talk. So in this case, I have a sample application, which is like a basic blog, let's say a blogging website, right? And we have a YouTube embed, which is a simple YouTube embed that I've just uploaded the video on YouTube. I've just used an iframe to embed it, right? Now, if we go ahead and play this, you have the most standard YouTube controls. You have, the player, which looks very good. It has all the basic controls like muting, and, you have the settings. You can actually change the playback speed. You have picture in picture, basically everything that YouTube provides, right? So it is very easy to integrate something like this. But then here comes the problem. So when you pause it, you have these unwanted ads, right? You have these very irrelevant recommendations that YouTube gives you. Now, for a very native-like experience, this is not the most optimal way, right? Because you have very little, or let's say no control over the experience that you're offering to your users, right? So that brings me to, the three disadvantages that I've mentioned here. So first, we have a lot of ads. Second, we have irrelevant suggestions. Third, we have no control over the experience, right? So now, what is the way forward here? So the way forward is, somebody would argue that, we could use platforms like Vimeo. So Vimeo is, again, it is ad-free, unlike YouTube. It is user-friendly, again, because they have their own platform. You can just upload, download videos from there. You can just edit. There's no setup needed for infrastructure because they have their own clouds. You can just upload your videos there. They have a customizable player as well, right? But now again, that is not cheap, right? That is very expensive. Again, you have very low control over the user experience because the player is given by Vimeo, right? Now there is no content discovery, which kind of puts you behind in the SEO part. And the most important disadvantage here is that you cannot really work with those cloud storages. For example, you have a typical video workflow. You are probably accepting videos from your users, right? Probably like a user review section in an e-commerce app. So you are asking the users to upload the video. Now you have a typical workflow where you would upload those videos to a cloud storage like S3 or let's say Google Cloud Storage, right? So in such a way, in such a case, you would not have, control over Vimeo, because in this case, you will actually have to duplicate those videos, upload them to Vimeo platform and then serve from there, right? So you're basically complicating the whole pipeline there. So this is the major disadvantage. Now, what is the way forward here? So the way forward is when you really want to, give this very amazing video experiences, which basically blend with your branding, blend with your rest of the user experience, user interfaces, user designs. The way forward is that you actually try to build these things natively, right? Because in this case, you will have completely customizable experiences. You can actually control over, your branding, your experience. You can actually get away with all the ads, right? If you don't want ads, you can actually get away with ads. But in case you want ads, you can actually, use your own ads, integrate your own ads, right? So because the main point is that you need to have control over your experience when you are building an application, right? And then they will be tailored to your workflows, right? So you need something which can actually work with your existing workflow where you kind of upload videos to S3 or store videos in a blob storage or any FTP server, right? Now, there are certain disadvantages of this method as well. So video processing is hard. I mean, accept it or not, it is really hard. It is computation heavy. It is, it needs a lot of learning curve from developers because you need to understand a lot of things, codecs, encoding, audio, videos, AAC. I mean, you've heard of so many things, right? H.264. So you need to understand how really you need to optimize these videos. Secondly, the computation, the infrastructure requirement is too heavy because you need to manage streaming. You need to, put forward a CDN, which can actually help you with global delivery. Also, you need to, shell a lot of money out of your pockets because, again, processing is very heavy. You need a CMS where your users, or let's say your admin users, internal users can actually, manage the whole workflow and the life cycle of videos. Now, this is exactly what we'll be talking about with the ImageKit video API. Oh, by the way, this is not a sales pitch for ImageKit. There are some of these concepts which are so generic that you can actually take them back and, kind of implement them in your existing applications. But with ImageKit video API, we'll be using that as the source of it because it actually makes a lot of things easier for me to explain these concepts to you, right? And it actually helps you integrate videos with the minimal effort that you need, right? So there are two ways that you can get started with the ImageKit video API. The first way is you can use our inbuilt ImageKit media library, which gives you like a native interface where you can actually manage your videos. So this is something what the media library looks like. You have all the ways you can just upload your videos. You can just manage it. So these are probably all the videos that we'll be using for examples. I've already uploaded them to a media library. This is one video that we'll be using a lot. I like the shuttle launch that happened recently. So, but yeah, this is one way of getting started with the media library where typically this way is useful for, those projects or those companies which do not have, video pipelines already set up so that they can use our storages, our APIs to just, get their workflow up and running in no time. The other way would be to actually bring your own cloud storage. So a lot of, bigger projects, bigger established projects already have certain pipelines already set up, right? So for example, you might be storing your videos over a bucket like S3 or, Google Cloud Storage or probably Azure Blob Storage or let's say any other FTP server. You would also be typically using a CDN like Akamai or CloudFront or Cloudflare to deliver these videos globally on a delivery network, right? So in such a case, you can actually bring your own cloud storages. And in this case, what happens is ImageKit kind of integrates as a layer between your existing storage and your client-facing applications. So I can actually show you how you can do that as well. So this is typically your, again, this is the dashboard. This is the image dashboard. You can go to external storage, and you can add like any storage. So we have Amazon S3. We have any S3 compatible storage, for example, Vimeo, right? So some people use Vimeo for self-hosting content. You can use GCP, Azure, anything basically. So this is how you can bring an existing storage over to ImageKit and use ImageKit just for optimizing and delivering native video experiences. Now, in a typical setup that ImageKit uses, this is what an architecture looks like. So you typically have a URL which is given by ImageKit. Now, this is a URL that you will typically be using in your client-facing applications, right? And what happens is when you basically make a request to this URL for the first time, what we do is we basically get the request on our video processing server. Now, your videos could be hosted either way, right? It could be hosted on cloud storages or on an ImageKit media library. Now, in both of these cases, what we do is we essentially process those videos, we optimize them, we convert them, into the most optimized format for different browsers, different network speeds, and we kind of store them on our layer, and then we deliver it directly to your clients, right? So this is a typical architecture flow of how a typical native video delivery using the video API looks like, right? Let's probably go into the code. So in the previous example, we just saw that, how easy it is to use, something like an iframe embed to, integrate videos. We can actually look at how you would, bring over a more native-like experience using the HTML video tag. So what we have is, in this project, I'm using one of the SDKs that ImageKit has, which is called ImageKit Next. Now, typically, we have a video tag, which it just looks like the HTML5 video tag because in a way, it's a wrapper over the native HTML5, which is supported by all the browsers. Now, what advantage this component gives us is it gives you all the basic, the HTML5 tag capabilities. Apart from that, it also gives the features that ImageKit has. It's just a wrapper that I'm using. Now, from the previous example, the only difference here is that we have a video tag. You can actually specify the source. You can specify some controls like autoplay if you want autoplay. If you want PIP, you can say that, picture-in-picture is enabled, accelerometer is enabled, and all of these things, right? Now, there are certain attributes that I would like to show you, and I actually show you how this looks like as well on the real application. So let's see, let's go back to the main page. And this is what the native experience looks like. So now we again have a player which looks very similar to the YouTube player, only much better because you don't have the YouTube logo, but you still have the basic controls. You do not have advertisements. Now, when you typically refresh the page, you see that the video is loaded. There's a basic buffering that's happened. You see the time, the total time of the video. You see the play controls. You see all of those things. You can go full screen. You have these other options as well. So in a way, we are one step ahead of the native, of the YouTube restrictions and Vimeo restrictions towards a more native experience, right? We can play the video again. Now, let me just show you what the request here looks like, right? So if we go to the network tab, let me just refresh the video again, and let me filter based on media. Okay. Just a second. Yeah, so in this case, if you see, typically I can filter space, and I think it's cached in my browser. Let's just open it into a new window. Right. I don't see the requests coming in. But in any case, so what happens typically in such kind of streaming is that you have something called chunk streaming, right? Because we basically started with a video which is, let's say, 35 MB in size. So this video is typically 35 MB in size in our media library. I can just show you the size. So this is a 35 MB video. Now, typically what happens is when you stream a video like this on, on a platform, on your apps, you cannot really load the whole 35 MB in one go, right? So what happens is internally, the browser chunks the videos into multiple streams, right? So basically, let's say it's a 35 MB video. It could be chunked in, let's say, 6 different chunks of 6 MB each, right? And then what happens is the player, so all the players, like the YouTube player, or let's say the native HTML5 player as well. So what they do is they request these chunks in a sequential fashion. And that is exactly how we see the buffering, right? So now the problem here is that, when you kind of, let's say use an MP4 video, MP4 is a format that might not be supported natively by all these different browsers, right? Or let's say you have a video which is AVIF, right? Or not AVIF, let's say you have WebM, right? So that might not be supported by all browsers. So for example, WebM is supported by Chrome, but not by Safari, right? And we have a lot of Apple users as well. So in a way, what ImageKit does is it makes sure that, whatever your device is, right, we would just optimize the video, convert the format, and deliver the most appropriate format to the most appropriate device, right? So this is all what ImageKit does for you, the video API natively. Let's move ahead. So like I said, right, we could use the native HTML5 tag, or we could use the SDK, which just gives you these options. Let me also show you some interesting things about this native video tag. So we have an option called preload none. This is again given by the HTML5 tag. Now, typically what happens here is that, let me go back to the example, right? So when we do something like preload none, right? So what happens is you see that there's no video loaded, right? There's no metadata. We don't know how long the video is. There's no thumbnail, right? So these are some options that you can actually use to improve your experience, right? So this preload is one of the options. We have different things that different values that preload can take. So none basically, instructs the browser that you do not have to preload anything, right? This could be good for cases where, you need to save bandwidth, and let's say your container is already fixed, but, you want to lazy load the videos in a way, right? So preload none could be good for that. We have another option called preload metadata. In this case, what will happen is, so in MP4 videos, we have something called MOOV. It's called a move atom, right? So that is basically more like a header for an MP4 video, which has information about the thumbnail that will be displayed before the video starts loading. It has certain information about, the range of the video, basically the start and the end time of the video, and different properties that the player needs to load that video in the proper container, right? So we could use that, which basically, holds the value metadata, or you can use something like preload auto. This will make sure that, all the metadata is loaded, and the initial chunk of the buffer is also loaded. So, right, so that it basically improves your initial video streaming experience, right? Now, this comes with a lot of problems. And by those problems, I mean that, let's say there's a user who started streaming your video, right? Now, suddenly his network speed dropped, right? Now, assume that your initial video was, let's say, a 4K video or a 1080p video, right? But let's say the user is suddenly on a 3G network. In this case, your video streams would not be able to adapt to this network change, right? Because you have a 1080, you don't have a different variation of a video. So now these are the problems that you still have when you are, building a native video experience. Now, what is the way to solve these problems, right? So the native HTML5 video player has a limitation that it cannot really, work with adaptive streams. So by adaptive streams, I mean streams that are intelligent enough to adapt based on the user's bandwidth, right? So in such a way, we could use something like Video.js player. So Video.js is an open source library that you can use in your applications, in your React applications. It inherently supports adaptive bitrate streaming as well. And again, it is a URL-based HLS manifest. So I'll basically talk a little bit more about what adaptive bitrate streaming is, how it happens in the backend, and how you can use it to basically adapt your videos to the changing bandwidth. Right. So let's say you were to upload a video which is let's say a 4K video, right? Now, in a typical setup, when you were to do this on your own, you would have to make these different video versions for a 1080p, for a 720p, for let's say 360p, 480p. You would typically make these different video versions with lower resolutions, and you would upload them to your bucket as separate files. And then you would typically create like a mapping file which says that, okay, for this bandwidth, you serve this video, this particular video. Let's say the user is on a 3G, serve a 480p instead of a 1080p because, it's going to buffer and we don't want buffering. So in background, ABS also works in a very similar way. It is very intuitive. So what happens is that, when you create these different encodings and different resolution videos, we typically create a manifest file, which is basically like a standard conventions. We have two conventions, HLS and dash for adaptive streaming. HLS is HTTP live streaming, right? So a typical HLS process would look like, you chunking these videos, creating the different videos, and you create something called a playlist file, right? A playlist file is something that exactly stores the mapping of what bitrate to what raw video file you want to serve over a certain bitrate, over a certain bandwidth, right? And now for each of these different playlists, you have all these mappings, right? So for 1080, you have a different playlist of videos, which basically also stores what chunk to call, like the whole chunk mapping, right? And all of this is stored in one single manifest, which we call is an M3U8 file. So in case of ImageKit, we call it ikmaster.m3u8. Then finally, your player is able to understand that particular manifest file and then adapt to the changes of the video and the user bandwidth, right? So this is typically what ABS is. Now, let's see, an example where we have the same video, but using the video.js player, which supports ABS. So this is again a player which looks very similar to the native HTML5 player. The only difference is, okay, we have the same thumbnail, we have the basic controls as well. The only difference is that, okay, the video plays as well. The difference is that we have this setting option which comes up because this video already has an HLS manifest and the video player is able to read this manifest, right? And now we can actually adapt to these different frames. And then we also have a setting called auto in video.js natively, which makes sure that, the whole switching is seamless, right? So in a way, what happens in the backend of this is that, when you're calling chunks, so like I said, right, there's a sequential chunking that happens in the browser, right? So we have little or no control over what that chunk size would be. For example, there could be a 36 MB video, right? And we chunk it into like a 6 MB pieces each. So typically a player like this would, start with the lowest bitrate chunk. For example, let's say in this case, it would be, what is the lowest here? Oh, this is 360p, right? So typically it would request for the 360p bitrate in the first request that it makes to the chunk, right? Subsequent ones, it will just make sure that it understands the bitrate of the or the bandwidth of the user, and then maybe request for a higher chunk. And then let's say the user bandwidth drops after a while, it would again request for a lower bitrate chunk, right? So in a way, this is how seamless the video looks like when you stream it. But this is what happens in the backend, right? And ImageKit Video API kind of, understand all these signals from the video player and make sure that we, serve the appropriate chunk at the right time, right? Coming back to it, let me show you how you can implement this using video.js. So we basically go to this file, right? So a typical video.js player looks something like this. So these are the bunch of effects that I've used to make sure that the autoplay and source and all these attributes work perfectly. But this is the most important part that I want to cover here. So these are some of the options that video.js gives you. So you can have controls which can basically control whether you want the video to autoplay on the page load or you don't want autoplay. Let's say you want the video to start muted. You can specify that. You can specify the width of the player, height of the player, all of those things. Controls have controls for like picture-in-picture mode, theater mode, and all of those things, right? Now, these are the sources. So sources is basically the source URLs or, the source places where you want the video to load from. And you can basically just say that, source, and there needs to be a URL here. Now, in this case, what we are using is the ImageKit API. So we basically have like an interface wrapped around it. And all you have to say is that the URL endpoint that comes from ImageKit. Now, in a typical setup, like I said, right, creating all these pipelines where you create these different formats of the videos, store them in buckets, figure out what to stream when, is a complex process, right? So ImageKit makes it easier for you to kind of, automate this by just adding the string ikmaster.m3u8 as a suffix to your URL. And in a way, internally, we will make sure that we consider that as an ABS video, ABS-enabled video. And now you also have to give us a transformation. A transformation is nothing but, again, a set of URL parameters that tell us that, okay, these are the different resolutions that we want the video to stream in, right? So if you see here, in this case, I'm using a prop, right? It's a prop. But effectively, I have just, passed that I want this video to be in these 4 formats: 360, 480, 720, and 1080. So internally, what happened is that the ImageKit API, the video API, it made sure that it created all these variants of the videos, and it's over the same video player, right? Now this is how we can implement. Again, we are discovering that this is basically the streaming manifest. This is the resolution that we passed. Coming to the poster, right? So there's one interesting prop here, which is called the poster prop. So let's say I don't specify a poster prop, right? Let's say I comment this out, and now there's no poster prop, and we can go back to our. So do you see the difference here, right? So the difference is that we have not loaded a poster. We have not loaded a thumbnail, right? Now, typically, this thumbnail is nothing but a simple JPG image or a PNG image or basically an image, right? That you pick from a video or they create on your own graphic, and then you just put it as a poster, right? Now, again, this could be a very tedious process. You would have to use, something like Canva or Photoshop, pick, design a graphic, store it to S3, and then, use the URL here, right? But with ImageKit, it is as easy as, just adding a prop. So we have a prop like, let's say, thumbnail start offset, right? So what it says that, pick the 22nd, pick the frame from the 22nd, second of the video and use that as a thumbnail, right? So when we just uncomment this, we can see that on reloading, we have a thumbnail which is from the 22nd second of the video, right? So that's how easy it is to use, our SDKs, in general, the video API, to make sure that you can bring more native experiences in videos. I think we have like 5 more minutes, so I can cover one interesting part as well, which is vertical video interfaces, right? So we might have all seen that, we have apps like Instagram, TikTok, we have the YouTube Shorts, right? Which give a more native experience in a way that they have vertical videos, right? So with a traditional setup, you would have to, let's say you shot the video in a landscape mode, right? You would have to crop those videos, make new formats of those videos with different resolutions. Let's say you want like a 640 by 320 video, right? So you would actually have to convert those videos, re-encode them, and then store them separately and then serve them on a mobile device, right? But with ImageKit, actually use real-time transformations. Again, these are URL-based transformations, which can actually help you do this in a more automated way in real time on the delivery side of it. So you don't really have to pre-process it and keep it, right? So what happens is, let's say I were to show you a demo of this app. I've already built like a native experience, which is vertical. So for example, this is something which is a vertical experience, right? Now I can actually hover on these and play a small trailer of the clip, which exactly what happens in something like Reels, right? When I just go over a next one, it just plays a trailer for the next one, and just when I just, take the mouse off, it just stops playing it, right? So, and when I just, click on it, this gives you a more native-like experience. Now, if this were to, translate on a typical mobile device, you would not see these black borders, right? Because this is a vertical video. So now, how would you do this with, something like ImageKit? So typically, it is again as simple as using the native tag that we have and using some of our props. So in this case, what I've used is I've used a transformation which just says that, we have to basically transform the video, the existing video, which was, by the way, a landscape video, into something like a 400 cross 600, because 400 is the width and 600 is the height. So it makes it a vertical video, right? And now those two transformations, the duration and the start offset, basically tells you that, okay, you have to play the trailer, which starts from the second of the video, and with the duration of 5 seconds. So basically, second to the 7 second. That is how we were able to make the mouse hover over the video and play like a trailer, right? So this transformation. We make sure that the video is muted for now. Now again, the same poster attribute that we saw, the same poster prop. So we are just saying that pick the poster from the second of the frame, second of the video, and use that as a thumbnail. Now to do that, all you have to do is, again, you don't have to really upload the image anywhere. All you have to do is use the same video URL and just append a suffix called ik thumbnail or JPG, and we will make sure that we pick the second frame and use it as a thumbnail, right? And then these are those events for on mouse hover and on mouse out that actually plays a trailer for you, right? Right. So I think we've covered this already. So in summary, I think we've mostly covered all the points here. So the way that ImageKit Video API handles the tough parts for you, the processing, the encoding that you would otherwise have to spend a lot of resources on, spend a lot of time on. We also help you with storage of process videos, which is why we are able to kind of deliver them very fast. We have a simple URL-based API, which is basically like a single product for all your media delivery needs. By the way, we also work with images. This talk was specifically for videos. All of these things are also for images. We have about more than 25 plus transformation parameters that you can use in any combination to do a lot of stuff with videos, about 50 plus for images. And again, like I said, right, you don't need an extensive setup because everything works on the URL. We have an integrated media library that you can use to, store and upload images and serve directly from there. We have a bunch of SDKs as well that actually help you manage all these flows, like I showed you. And yeah, I think that brings me to the end of the session. I hope it helped you take some important concepts back. With or without using ImageKit API, you can help, use these concepts in your apps and deliver a more native experience, which is away from something like YouTube with a lot of ads or Vimeo, which is expensive, right? I think that's it from my side.